In this lesson, we're going to be talking about the slope of lines. If you have a line that rises upward to the right, it has a positive slope. A line that falls downward to the right has a negative slope. A perfectly horizontal line has zero slope, and a perfectly vertical line has an undefined slope. Now, slope is equal to the rise of a line over its run. And we'll be seeing how that works in just a minute, really what that means. But this is the formula that we use to compute slope. M is the symbol that we use for slope. So we will probably not write out the word slope all the time. We'll just write M. If you have 2 points, now your first point is called x1, y1, and your second point is called x2, y2. If those are 2 points on a line, then the slope is found by saying y2 minus y1 over x2 minus x1. Now let's use that formula to find the slope of the line containing the following points. We have negative 3, 4, and 2, negative 2. We're going to start by labeling our points x1, y1, and x2, y2. And we'll use the formula m equals y2 minus y1 over x2 minus x1. So let's plug our numbers in. y2 is negative 2 minus y1, which is 4, over x2, which is 2, minus x1, which is negative 3. So we have negative 2 minus 4 is negative 6. And these two negatives become a positive, so we have 2 plus 3, which is 5. So the slope is negative 6/5. So this is the rise over the run of the line containing those 2 points. Now let's think about what that means. Let's go back up here where we've got a little more room. If you start at a point and your slope is negative 6/5, that means that you are going to drop 6 spaces. Now I'm just going to imagine this is 6 spaces. And then I'm going to go right 5 spaces. And you can imagine that there is a line connecting your starting and ending points. The negative 6/5 represents the slope or the steepness of that line. All right, so that's what the rise over the run part means. Now let's find the slope of the next one. We have x1, y1, and x2, y2. So let's plug our numbers into the formula m equals y2 minus y1 over x2 minus x1. So we have 3 minus 3 over 4 minus negative 1. Well, 3 minus 3 is 0. 4 minus negative 1, the negatives become positive, gives us 5. So 0 over 5 is just 0. So the slope is 0. So if we go back up to the top, a line with 0 slope was just a horizontal line. I didn't ask you to say what type of a line this is, but we can add that to our information here. Okay. Next, we have the points 2, negative 2, and 2, 4, and we want to find the slope of the line containing those points. Again, let's write out the formula. If you keep writing out the formula, it will really help you to memorize it. So we have x1, y1, and x2, y2. Plug our numbers in. So we have 4 minus negative 2 over 2 minus 2. 2 negatives in the numerator become positive, so we get 4 plus 2 is 6 over 0. Well, you cannot divide by 0. So this answer is undefined. So this has an undefined slope. Going back to the top, we said a vertical line has an undefined slope. So we can even go a little bit further and tell you what kind of a line this is. This is a vertical line. And let's move on to the next one. Negative 3, 8, and 1, 4. So again, write your formula. y2 minus y1 over x2 minus x1. Plug in your points. So I have 4 minus 8 over 1 minus negative 3. So I get negative 4 over positive 4, which gives me a slope of negative 1. Moving on to the next page. Slope is just simply a rate of change, and the rate of change is equal to the change in the dependent variable divided by the change in the independent variable. So we can think of this as a change in y over the change in x. Remember, dependent variables are represented by y, independent variables are represented by x. Now it says the table shows the average temperature in degrees Fahrenheit for 5 months in a certain city. Find the rate of change for each time period. During which time did the temperature increase at the fastest rate? Now, the month is our independent variable, so this is our x. The temperature is the dependent variable, so that is the y. Because the temperature really does depend on the time of year, which was represented by the month. So that's why we choose months to be independent and y to be and temperature to be dependent. So let's think about it. Let's see what the difference is in temperatures as we move from the month to month, or the difference in the months is. Okay, from month 2 to month 3, we have a difference of 1 month. And we have, between months 2 and 3, a temperature differential of 0 from 56 to 56. So we say that the rate of change, remember we put the y over the x, so we're going to the change in the y over the change in the x. Change in y, the temperature was 0, over the change in x was 1. Okay, so basically the change was 0 over 1, or just 0. Now from months 3 to 5, we had a difference of 2 months, and the temperature went from 56 to 63, so that's positive 7. So we put the y value, change in y, which was 7, over the x value, which is 2. Let's go to the next one. From months 5 to 7, we had an increase of 2 months. And from in between months 5 and 7, we had a change in temperature from 63 to 71, which is 8 degrees. So if we write the change in the y over the change in the x, we have 8 over 2. From months 7 to 8, that's a difference of 1 month. And the temperature increased from 71 to 72, so that's a difference of 1 degree. Change in the y is 1. Change in the x is also 1. Now, it wanted to know at which time period did the temperature increase at the fastest rate. Well, which one of these rates of change is bigger? 0, 7 over 2, 8 over 2, or 1 over 1? Well, it's 8 over 2. 8 over 2 is the bigger temperature. In fact, that is 4 degrees per month. Okay? And that occurred between, well, let's see, right here, between months 5 and 7. So we'll say between months 5 and 7, the temperature increased at the fastest rate. Okay, now moving on. We want to find the slope of these lines, and I've written here, just to remind you, slope is equal to rise over run. So let's pick a starting point. Say we pick this point, and you notice they are highlighted for you. How far do you have to rise up and run over, or your rise might be down, you might fall too, to get to the next point. Well, it looks like we had to rise 1, 2, 3, 4, 5. So we went up, so it was a positive 5. And we ran to the right, so that was positive. If you're going to the right, it's positive 3. So the rise over the run is 5 over 3. Let's look at the next one. To get from one point to the other, so if we start with this point, looks like we have to go down 2, so that would be a negative 2. And we move right 1, 2, 3, 4, 5, 6, 7 up, and that's positive since we're moving to the right. So we have a slope of negative 2 over 7. So let's move on to the next page. Here is slope and y-intercept. Slope-intercept form is written in the form y equals mx plus b. M is your slope, and b is your y-intercept. Now let's use that information to graph these lines. So we have y equals negative 2/3 x plus 1. So here's your y-intercept of 1. So we're going to start by going to 1 on the y-axis. Your slope is negative 2/3. So that means we move down 2 and right 3 to get to our next point. Down 2 and right 3. Down 2 and right 3. And now we can just connect those points. So that's another really quick way to graph. Let's do the next one. We have y equals negative 1/4 x minus 1. Your slope is negative 1/4, and your y-intercept is negative 1. Always start with your y-intercept. So we're going to start with negative 1, and our slope is negative 1/4. So we're going to move down 1 from that point and right 4. And we'll keep doing that, down 1 and right 4. And now we can just connect the points. The next problem, your line is not in slope-intercept form, in y equals mx plus b form. That's what we call slope-intercept. So we do want to get it into that form of y equals mx plus b. So we are going to have to solve that for y. So we're going to start by subtracting 2x from each side. And we get negative 3y equals negative 2x plus 6. Divide everything by negative 3. And we end up with y equals positive 2/3 x minus 2. Now our equation is in slope-intercept form. 2/3 is your slope, and negative 2 is your y-intercept. So start with negative 2, the y-intercept. Now your slope is positive 2 over positive 3. So we're going to rise up 2 from that point, and then run to the right 3. Rise up 2, go to the right 3. Up 2, right 3, and now connect those points. Moving to the next one. This one also is not in y-intercept form. So what I would like you to do is try this one. Solve for y, and then graph with the slope and y-intercept. So please try this one before the next class. Thank you very much for joining me.